Cool. Welcome to another GoTools call. I believe this will be a short one. I will share the link to the agenda here again, in case anybody doesn't have it yet. It's pretty light, but I'll leave pauses in case anybody wants to add any last minute items. So under ID/editor/tools, I believe Kent has an item here.
Yeah, I apologize if I should have put this under miscellaneous or whatnot, but I just wanted to share like a little update on the taint analysis package that I've been working on. I mentioned this at a previous GoTools call, maybe several months ago at this point. And one of the kind of, I guess, 4 core things that I've done to it thus far is add an interactive REPL to load and inspect the programs and look at the call graph and be able to like do a quick taint analysis to see like, is there a path, like can I actually go from main to this specific function, and can it be tainted by a specific type? So like the very basic example that I show in the repository being, can you call a SQL query and can it be tainted by a network HTTP request? So I think like trying to make the analysis and just like the underlying like call graph a little bit more debuggable is kind of like the core reason why I'm building the REPL, and also just make it easier to like kind of build other taint analysis tooling on top of the packages that it's sort of using under the hood. And speaking of the packages that it's using under the hood, it's now using the standard call graph package. Previously it was using basically a small fork of the call graph package, but now it's using the standard call graph types, which allows also me to do these apples to apples comparisons for like the VTA or the RTA or even the Go Vulncheck call graph, which is like, I think a mix of at least 2 of those. But that's something I'm using to then have a CSV output, which is the next point. So with the call graph that we get from a given program, we can want to visualize that. So I have like the REPL of like kind of one way to inspect that. So when you have like very large programs like Vault or HashiCorp Vault, for example, is very unwieldy and kind of requires like multiple views and then the kind of understanding like what's maybe missing as links in the call graph, what might need to be added, kind of et cetera. So I've added the CSV output, which can be very quickly used to do visualizations in things like D3, for example. And in the examples link in the notes, I have a bunch of examples for Vault and for Tailscale and some of the interesting programs that are these SVG representations of the call graph of the given program. And you can kind of then hover over any of those nodes. It's not super nice and interactive right now, but you can hover over any of those nodes to see like, oh, like what function is it representing? You'll see like at the middle of a lot of these, very large programs, format error F being like a very, very key thing that's called all the time. It makes a lot of sense. But it's just like, it's pretty visual and it's like actually very useful. Because if you look at the edge, I apologize, I don't have the picture up right now, but if you look at the edge of these very like unwieldy call graphs, the very edge, there's these kind of like missing functions that aren't linked into main by any point. And this is actually like a limitation in my current call graph construction that I have detailed in an issue in the repository. But it's basically like having to map structs that have functions inside them as a field, and then they're being like iterated over through like a slice, and then having to like figure out how to like map those things. Like it seems like, at least in like the basic like SSA like value graph, I'm missing some like links or like they're non-obvious links at the very least. So I need to go figure out how to track those down. So definitely looking for feedback on that if anyone like takes a look at that issue and see something interesting. Oh, Alan, yeah, go ahead.
All right, so just one thing you might want to look at is there's a tool I wrote many years ago called Spaghetti, and you can find it.
Yeah, very familiar.
Okay, so it's a browser for looking at large graphs of Go modules, but you can just rip out modules and replace it with any DAG at all, and I found it to be quite a convenient way in terms of screen real estate and so on for looking at big graphs in a sort of purposeful way. When you're trying to say A depends on what, and then you pick one of those things and you say why does it depend on it, and it shows you an arbitrary path. It also shows you which nodes in the path are sort of critical nodes. In other words, you have to go through them. They're actually dominators in sort of graph theory. And this can give you kind of like a sense of like, what do I need to cut if I want to break a dependency between A and B or A and C? So you might want to take a look at that, because every time you use graph viz to visualize these things, they're pretty up to like 50 nodes. And then
totally.
Balls of spaghetti.
Oh yeah, and if you try to like not have like that like cross paths or whatever, like that little like literally take till like the end of time to complete generating. So like, and that's actually a D3 for whatever this is worth, observable, and then using like D3 has been like at least like very, very nice in terms of like it can like read at CSV, and I can like have a table view, and then I can use that. So it's kind of like a Python Jupyter notebook, but like you can have that like table view filter down, have like a search inbox in observable, and then have like a graph thing. I don't have this public right now, but like I'm definitely to that exact point of like trying to like there needs to be tools to like inspect these things, and I'll definitely look at Spaghetti because I think having like a more custom or purpose-built thing to like load a program and then like be able to inspect these things would be way more advantageous. So I'll definitely take a look at that. Thank you.
Yep. And I think you mentioned that you're finding there are call graph edges missing. Which algorithm are you using to build your call graph?
This is me. I'm not using VTA or RTA or anything like that. This is me looking at the SSA directly and then building the call graph from there.
Okay.
So it's not necessarily as, I don't know.
Sound.
Yeah, but I'm for whatever it's worth. Like when I'm like looking at the program and I'm looking at the call graph that I'm building from the SSA, like it seems to I'm seeming to have like some like random amount of control here to like handle things like interface calls like in a very particular way, because like those are like these like weird virtual function calls. Like I'm having like I'm like weirdly, maybe I'm mistaken, but I'm like finding myself like almost needing to inspect the SSA. Like I'm finding myself like using like the other call graph constructions are like for lack of a better word here, failing me to like give me the resolution that I need.
So dynamic calls have always been the hard part of building a call graph, and
Totally.
there's a whole bunch of algorithms. There's a summary by Craig Chambers in a paper that's linked to, I think, from one of the packages, maybe from the RTA package. But that gives you an overview of the various algorithms that existed in the 90s, and I don't think there's been a huge amount of progress since then.
Yeah.
But the RTA is kind of the cheapest sort of decent one we've found. Our VTA is more expensive. It also works on partial programs, but RTA, if you're starting from main, will give you a pretty good and sound result. In other words, you really can delete the functions that it doesn't report as live, except for the ones that you get through C and assembly, which should be very,
of course. Yeah. But even in those cases, like I'm still like, I could be mistaken here, but I'm still like finding that to be like missing information that I find like crucial in the program. So maybe it's just like my mistake, and I'm going to continue to like pull on this thread and like still look at these call graphs. That's why I have like building these inspection tools to like really get a good feel for them. And of course the Go Volncheck one is like another like call graph that's made up of this construction of like things like CHA and DTA, something like that. Whatever the case is.
CHA's so dumb you should not use it. It's kind of like the simplest thing you could possibly think of, and it's implemented in a very efficient way as well. So don't use that at all.
Fair. So like again, I'm going to continue to pull on thread and hopefully continue to share progress. But I think like at least those CSV outputs would be reusable for any of those other call graph things. So we could do again like pure apples to apples comparisons. Like why does this have this link but this one doesn't have this link? And if I could have more better debuggers like actually diff call graphs, that's something I'm continuing to look into. And then as like a last sort of point here, while I've been doing all this like call graph and package load and all this like nonsense, been looking at Go Volncheck to like rip out its call graph construction. I've noticed that there might be some optimizations to add to Go Volncheck or share in Go Volncheck, wherein like when we're parsing the AST for like these large targets like HashiCorp Vault, for example, like we're doing an AST like parsing comments and doing object resolution. If I am correct here, so that might be like a quick optimization, because I don't necessarily believe we need to do those, or at least one of them.
Right. Both of those I think we could probably get rid of.
Yeah, so I think like that would be like when I like do a trace and like I do package loading, that's like for like on these large programs, that's like one of the bigger things that I'm seeing in traces. So I think we'll be able to get like a fairly bit like memory saving. Like I think last time I did this on Vault, I saved like 4 gigs of memory, just like skipping that. So I think that's something I wanted to add.
A lot more than I expected, actually. I think the big problem with ETA, last I remember, which is used by Volncheck, is that it does actually, I think, build the CHA representation first. Or
it does CHA first and then VTA twice. Or something like that.
You really should just fork the CHA code and do something, because the CHA code is trying to fit into the call graph API, which is really not a good representation of CHA call graph. Branching. So you should just like write a bespoke version of that and use that as a starting point, and it'll be much more efficient. But it's essentially expanding enormous cross product unnecessarily. So I think that was the biggest cost last time I checked. But
yeah, I think there's definitely like there's definitely optimizations like to be had there, which I think will be like very, very key. Again, like to run Go Volncheck on like, I'm just using Vault as an example because like one of the larger like weird like unwieldy old kind of like code bases that we can use as an example. Like that will use up like 19 gigs of memory and like all my CPU, and like that's and like basically for the source. So like the binary is obviously be faster, but like for that source, it makes it like not friendly to use. Like I don't want to use it's going to take up all that CPU and memory. So I definitely want to like contribute like those optimizations and like have like a good like trace comparison in the near-ish future. Whenever that timeline is, hopefully sometime in the near like beginning of this year, I plan to like make a pull request to
Yeah, sure. Send me a
try to add
share
that.
if you're willing to do that. Have it.
Yeah, that's my goal at the very
Yes,
least.
thanks.
Cool, and that's it for me. Thank you.
Thanks.
Cool. A few more items onto this section. The next two are mine. They're pretty short. One is just a brief thanks for whoever is working on the support for GoDoc links in GoToDefinition, because I keep hitting that button even though it does nothing. So in Go Please, that is. And also an FYI.
Yeah, that's an external contribution. So thanks to them.
And a brief FYI, this is actually from November, but I don't think I brought it up at the November call. When I went to GoLab in Florence, I met Alessandro, and he wrote this tool, and he apparently never talked about it, but he did do the talk at GoLab on it, and I think it's pretty cool. It uses I forget what they call. Oh yeah, the dump dependencies flag from the linker, and then it tells you why the dead code analysis is disabled in the linker. So it will tell you, oh, you're importing this package, which then uses reflect.method. And then because of that, it's just disabled for the whole binary. So it's pretty cool. It's also a bit exasperating that you run it on like a medium-sized project, and there's like 10 reasons why it's disabled, but at least you know why.
I didn't realize it actually eliminated dead code, switched off dead code elimination. I thought it just was more conservative about which things it would prune. But maybe that's the same way, different way of saying the same thing.
Yeah, I think it's the same thing. Yeah. The next item doesn't have a name, but I'm assuming it's going to be Rob.
That is me. Sorry. Yeah, I thought I would just use this opportunity to say that we're working on getting the next minor version of Go Please out in the next few weeks, hopefully. In this case, the major features are automatic workspace detection and automatic build tag detection. So both of these amount to Go Please trying to do the right thing when you open a Go file. So figure out which module you're trying to work on and configure workspace accordingly. And if the file has Goose or Garch constraints, applying those constraints to the workspace as well. So it's kind of like a risky change. So we've already cut the pre-release a week ago, but we're going to let it soak for a few more weeks and probably try to promote it a bit and get some more testing. I'll do that in Slack and on the issue tracker. But yeah, we're really excited for this. This is kind of like the last missing piece resulting from the scalability work, is that we should be able to do this. Dan?
One quick question. I use the remote equals auto flag for the sake of saving resources if I work in multiple modules or workspaces. Does that mean that now with this feature, I might, again, have multiple Go Please instances if they use different build tags? Or how does it work?
So the way it works is sort of internal to the session. So you wouldn't have multiple sessions, but internal to the session, we have a concept of a view, which is essentially a build context along with state. And what we did with the scalability work was try to sort of reduce the size of that view as much as possible. And so now we felt comfortable automatically adding additional views if we determine that they are necessary to work on whichever files you have open. So at this point, the largest source of memory consumption inside the session is file state, and that is shared across views. So each view essentially just has a little bit of state, which is used for optimizing sort of read type checking open packages. So we keep the import graph of open packages around so that we can read type check as fast as possible. We keep a fixed size cache of parsing results as well, but that's shared. So we think that sort of the incremental overhead of each additional view should be minimal.
In space, that is.
In space. And then in terms of in time, we're still working that out. So right now, the way it works is each file belongs to one specific view. So the common case of editing that file will only trigger sort of fast invalidation of that one view to get type check results for auto completion results. But then eventually, when you try to find references or when we try to diagnose the entire workspace, we have to diagnose everything that contains that file, which if it's a low-level file could be many views. So this could potentially increase the total CPU significantly, but we think that that's mostly acceptable because all this work is delayed. But we'll see. This is one of the things where that makes it a risky change. Some people have already asked for us to go even further and sort of detect all possible Goose and Garch combinations in the workspace. And we're not doing that because it's too risky and probably infeasible. But as we work on more refactoring stuff, we might want to try to have some heuristics for the set of build constraints that would cover the entire workspace for refactoring operations. But we have not solved that problem yet, nor are we going to in the near future.
Just to footnote there, so if you open like a underscore Windows file on a Mac, for example, now it'll actually have two sessions, two views, that is one for each of those platforms. And so it'll appear that the Windows references works as transparently, which is really nice. But it does mean that now when you make changes, you're actually doing twice the work of type checking and so on behind the scenes. So there's an amount of bookkeeping work that it has to do to keep up is proportional to the number of different configurations you have open. So if you open a high-up package that's full of I know every OS combination you can imagine, you're suddenly demanding a lot more work out of the system.
If you open up, so we will at most have one additional view per open file if every single open file somehow hits a different build constraint. So you'd have to open up all the files, but yeah, it could be potentially costly. Dan?
So in this new system, if I open a file that's either Linux or Mac, and then I go to definition in a function, and that function has different implementations for Linux and Mac, what is it going to do?
It'll do the one that's associated with the view that you're in. So it won't give you the union of answers today.
What?
It won't give you the union of answers.
No.
It'll give you the one that
it will pick one.
It'll pick one, yeah. And so if you're in a Linux file, it'll only give you the Linux answers. If you're in another file, it'll probably be the one that defaults to the machine you're on. But there's essentially two different structures there, and it picks one and then gets the answer from that one.
So a different way to think about this is a file with no build constraints matches all possible ports. And so we would have to do this analysis not at the location of the pointer, but at the destination. And so we'd have to detect what possible definitions in any possible port could this be jumping to. And because of the way like Go list works and because of the way the type checker works, the entire the tool chain operates on one port at a time. So we either have a choice of doing 50 times the work because there are 50 supported ports, or implementing some sort of heuristic. Like if you jump to definition and that definition is in a directory, we can look at ignored files in that directory and parse them and look for declarations that might match the definition. And then we could do things, but it would in order to not do 50 times the work, it would require us to implement some heuristics, and those heuristics are liable to be buggy, and we'd rather not do that for now.
I guess where my mind was going was more like, if I open a file and the heuristic has decided to just do Linux, AMD 64 for my laptop, for example, it might be nice for me to tell it, no, actually, I also want Mac, but I'm telling you, right?
So one thing we could do is allow you to specify a fixed set of configurations that we always run. And I think that's a reasonable thing to do. We're just not doing it yet. But if you want to declare, I'm working on Linux, Mac, and Darwin with this architecture, then we could conceivably always process all of those build configurations. But we want to see sort of what people actually need.
And it is a multiplicative factor on CPU cost.
Yeah. I mean, but it's not necessarily. So we only need to sort of eagerly do work for one build configuration because we just need something to input into auto completion essentially. So it's not necessarily 3 times the work, but it's more work for sure.
Cool. I think that's the end of this section. We don't have anything under Command Go. I don't know if Brian wants to mention anything.
I don't really know of anything to mention for what's going on right now. So we're fixing a few bugs in 1.22. That's about it.
Anything in particular in 1.22 that we should be testing?
Not really. A lot of what's going on in 122 is just bug fixes from the toolchain upgrades in 121.
Cool. Go SSA.
So that was me. So this week we've been sort of talking a lot about our plans for this year, and without going into too much detail, one of the big things is refactoring, which we plan to spend a lot of time just making sure that all the refactoring features we offer through GoPlease actually work in all the cases that they should. There's a lot of edge cases, I think. But another thing is trying to improve our sort of analysis frameworks, leverage, basically improve the infrastructure so that we can write better analyzers. And one of the things we've identified is that the SSA construction has been a real bottleneck in GoPlease. It's the reason we haven't had SSA-based analyzers in GoPlease until this release coming. And even then, that one does not use facts, and I think still cannot use facts for performance reasons. So the main issue is that the SSA, which was kind of designed without really thinking separately, without me thinking clearly about the difference between the whole program and the sort of modular package at a time kind of analyses, ended up gravitating in its API design towards a sort of whole program analysis bias. And as a result, you're supposed to create so these stub packages for all of your transit dependencies before you can build SSA for a single package. And of course, as you get higher up the stack, that means you're doing a lot of construction of these APIs just for almost no use at all. You may not even pull a single symbol out of that package. So what we'd like to do this year, one of many things we'd like to do this year, is to change the SSA public API so that you just aren't required to call create package for anything except the package you're actually trying to build and analyze. And the tricky thing is trying to navigate these changes within the strict letter of backward compatibility, because there are public fields that say that every symbol has an associated package structure, SSA package structure, and that will no longer be true. So we need to kind of provide ourselves sort of a plausible way in which we're preserving a certain kind of compatibility for the use cases that actually matter. And I think very, very few people actually build these kinds of analyzers themselves, and probably half of them in the world are in this virtual room right now. So I figure we can navigate this in a way that doesn't require us to sort of just make this much more difficult than it needs to be. So anyway, heads up, there will be changes coming to SSA. It should be easier to use and create less stuff when you want to analyze a single package. And what would be really nice is if we can just make these changes in Dominic's port of SSA, which is very similar in sort of broad strokes, so that all of the analyzers it has also benefit from this optimization in static check.
Cool. Onto miscellaneous. There's only one item that's mine. I just wanted to make a brief mention that having the wiki on Gerrit is amazing, because the last change I made to the wiki on GitHub, I managed to make 2 mistakes, which Rob spotted. So yay code reviews, because otherwise apparently I can't be trusted. But it's also a lot nicer to be able to just do a git log, etc.
And it's indexed by Google search.
Only took a decade.
Yeah. I have a question about Gerrit. Does anyone have a favorite way to do Gerrit-based code reviews on GitHub repos? Is that a problem that's been solved already?
I mean, we solved it
Google 3 for the Go project.
for the Go project.
That it lives in GitHub org, right? It doesn't live in GitHub.
Oh, you say, oh, you just want to use Gerrit?
Yeah,
I don't know.
Exactly.
Yeah.
I found a thing called Gerrit Hub, which but it's want to own its own Git repo underneath. Anyone use such a thing?
We use Gerrit Hub for Q, and we also accept PRs, but we don't try, when somebody sends a PR, we either say, hey, you're sending many PRs, can you please send them to Gerrit directly? Or if it's their first one, we try to be nice and we review on GitHub, and when it's finished, we just import to Gerrit and merge there.
Gerrit is the authority, is it? As Git repos go.
Yes.
Okay.
But we don't have anything that tries to mirror the review, because we don't think it's really worth it.
Yeah, sure. Okay, yeah, I'll just do that. Thank you.
Cool. Any last minute items or anything that we forgot? In terms of next call, I'm looking at March. So how's March 20th, for example?
Works for me.
So, yeah.
Go for it, Kent.
Oh no, I was trying to do a thumbs up and I hit the wrong thing. I'm so sorry.
Whole hand up. 5 thumbs up.
Yes.
Sounds good then. I will upload the video probably tomorrow, and then set up the next call over the next few days. And see you all in 2 months.
Thank you very much.
Thanks, Dan.
Everyone.
See ya.